Good morning for fourth period, afternoon for fifth. I'm not here today. I'm with the golf team over in Winchester today, playing in a golf tournament. But hope that you guys are doing well. Hope you're having a great day so far. We're going to pick up where we left off. Now, I made it a little bit further in fourth period than I did fifth. So I decided I'm just going to kind of go back through it real quickly and do just a kind of a quick review. It never hurts to hear a little bit more. We're almost done with the lesson, and then we're going to do some examples together, and then it's going to be time for homework anyway. So you're going to have plenty of time to work on your homework today in class. So just bear with me and remember what we talked about yesterday. The first thing that we said is, hey, when it comes to these transformations, if it happens on the inside, it represents a horizontal transformation. But if it's happening on the outside, it's going to represent a vertical transformation. And we spent quite a bit of time talking about these shifts, right? When something's being added or subtracted, we talked about if it's outside, it's going to shift vertically. And we said, of course, it is what it is, right? Like if it looks positive, it's a positive vertical shift, so it goes up. If it looks negative, it's a negative vertical shift, so it goes down. But then we said if it's on the inside, of course, it's horizontal, and I told you that it's the opposite. So if it looks like a positive H, it's actually a negative H horizontal shift, so it would go left. But if it looks like a minus, it's actually a positive horizontal shift, so it's going to shift to the right. So we talked about this. We did these examples, added these examples, but then we moved on to dilations. And I was able to show you guys using a hairband what these dilations kind of look like. And we talked about how instead of calling them dilations, we're going to call them stretches or compressions. Stretch or compress. Okay? And we made it through a lot of this. So bear with me as I go back through this, making sure that you guys do understand how this all works. Okay? So here's what we said. If we're dealing with any value of A that's greater than 1, okay, look, this is greater than 1 right here, and this one's greater than 1 right here. I told you when that A value is greater than 1, it means your graph is getting more narrow. It's getting more narrow. And sometimes it's getting more narrow when you're multiplying by the outside, and sometimes it's when it's on the inside. Now, they follow a different rule, so we'll come back to that. And then I want you guys to also notice that when your A value is less than 1, so that's like a 1/2 or a 1/3 or a 3/4 even, that is going to make your graph wider. So when that value that you're multiplying by is less than 1, your graph is actually going to, whatever your shape is, it's going to get wider. So it's all about where it happens. So earlier we talked about how if it's on the inside, it's horizontal. If it's on the outside, it's vertical. So look at these first two. When it multiplies on the outside and your value is greater than 1, what we said happened is this. I basically take this figure, okay? So let's use a V, like I did with that hairband. If I were to take my hand right here and I grab the bottom of this, there's a hand, that's pretty good. If I grab the bottom of that V and I vertically pull it this way, I vertically stretch it, what it will do is it will make it more narrow. So if this value of A is greater than 1 that we're multiplying by on the outside, to make it more narrow, it does this thing called a vertical stretch because it pulls it vertically and it makes it more narrow. Now, let's go the exact opposite direction, okay? Again, let's say I take my hand, and this time I'm not pulling it down, okay? I'm not stretching it down. Instead, I compress it. I push it up, Okay, so I push it, and what it would do then is it wouldn't make it narrow, it would flatten it out. And if it flattens it out, it makes it wider. So when I do that, when my A value is less than 1 and it's on the outside, I do this thing we call a vertical compression because that's what makes it wider. I think that makes sense. And I showed y'all that yesterday. So hopefully you guys are with me. So when I look at this, here's what I would love for you to process. You ready? I would love you to say, okay, I'm multiplying. That's a dilation. That number is greater than 1. It's going to get more narrow. There's no parentheses, so it's on the outside. That's vertical. What vertical move makes it more narrow? Well, that's a vertical stretch. That's how I would love for you to process this when you're processing it on your own. Okay? So again, watch this. All right, I see this number being multiplied. That's a dilation. Well, it's less than 1. It's going to get wider. Well, it's on the outside, so it's vertical. What vertical dilation makes something wider? A vertical compression. A vertical compression. So I hope this makes sense. It's pretty simple, really, if you follow the reasoning. Now let's switch gears. What about when we multiply on the inside? Well, it works differently. You see, we're not vertically stretching. We're not vertically compressing. We're horizontally stretching or horizontally compressing. So don't forget the main thing. If it's greater than 1, it has to get more narrow. If it's less than 1, it has to get wider. So here's the point. If I'm multiplying by a number that's greater than 1 on the inside, it has to get more narrow. So think about this. From a horizontal standpoint, not vertical anymore, if I took my hand and I yanked it this way and I yanked it that way, wouldn't that be a horizontal stretch? Well, yeah. Well, if I horizontally stretch this thing, wouldn't it make it flat? It would make it wider. That's not what I want to do here. I'm trying to make it more narrow. So I horizontally compress it. I smash it. Because when I horizontally compress it, it gets more narrow. So here's the point. A horizontal compression makes it more narrow. So technically, what is a horizontal compression more like? Well, it's definitely more like a vertical stretch because it makes it more narrow. I hope that makes sense. And I think it does. And vice versa, guys. If I am going to deal with an A value that's less than 1, I know it's going to get wider. So if it happens on the inside, it's going to get wider horizontally. Well, what horizontal move makes it wider? Well, that's definitely taking that V and stretching it this way and stretching it that way. That's called a horizontal stretch. So sure enough, a horizontal stretch is a lot like a vertical compression. Okay? They're very similar. So let me let you process this. Okay? Here's what I want you to see. I want you to see the value of 2. And I want you to think, hey, it's got to get narrow. Well, where is it being multiplied? Inside. Inside makes it, inside makes it horizontal. So what horizontal dilation makes it more narrow? Well, that's a horizontal compression. That's how I want you to focus on this. Because a horizontal compression, it compresses it, it smashes it, where it gets tighter, it gets closer. Okay, so last one, how do I think this one through? So here's what I do. 1/2 means it's got to get wider. It's got to get wider. Where is it happening? Inside. It has to be horizontal. What horizontal move, what horizontal dilation makes it wider? Well, by taking it horizontally and stretching it. A horizontal stretch. And that's it. That's how this works. It's not rocket science, but it is sometimes a little confusing. You got to follow the logic and you'll understand it, okay? Last one is the last type of transformation that we're going to talk about, and that is our reflections. Now, I know you guys can clearly see what makes it reflect. Look, it's adding that negative outside of it or inside of it. So it's multiplying by a negative. Okay, multiplying by a negative will make it reflect. So here's the deal. Remember the rule? I told you guys that these things can happen outside, they can happen inside. So when this negative is outside, that's what I like to call a vertical reflection. Now, vertical reflection, guys, vertical reflection. Think about what that means. Okay, if I have a coordinate plane here, there's my y-axis, there's my x-axis, and I have some figure drawn. Let me draw a v for an absolute value function. Actually, you know what I'm going to do? This is giving you a square root function. So let me just draw a square root function, something like this. Okay? Now, listen. If this negative happens outside, that's a vertical reflection. Well, what does a vertical reflection mean? It means that instead of, or it's going to basically mirror image off of that line right there. Well, what is that line, guys? That is the x-axis. So it reflects over the x-axis. That's how you consider this. It reflects over the x-axis. Okay? Now, what if it happens on the inside? Well, remember, inside is always horizontal. So this is going to be a horizontal reflection. Now, what in the world does that mean? Well, let me show you. Horizontal means it's going to reflect left and right. So what is the axis then that this thing's going to be reflecting over? Well, it's going to be reflecting over the what? The y-axis. And that's what's going to cause that thing to look like this. And that's just a sketch. But that is what we call a horizontal reflection. A horizontal reflection is where it reflects over the y-axis. And that's how I want you guys to describe these reflections. So when you see this right here, here's what you process. Okay, the transformation I see is a negative. Where? Outside. That's vertical. Vertical reflection. That means it reflects over vertically x-axis. It reflects over that x-axis. Okay, here's how you process this one. Okay, I see my transformation. It's a negative. Well, it's inside. That's horizontal. That's a horizontal reflection. Horizontal reflection is left and right, so that means it's reflecting over horizontal, the y-axis. And that's it with reflections. They're really pretty simple as long as you can keep the directions straight. Okay? Outside's vertical reflection, which means it's going over this x-axis. That's vertical reflection this way. Inside, it means a horizontal reflection, so it's reflecting left to right. It's reflecting over the y-axis. Very simple if you just follow along. All right, so let's look at some examples together, and then you can have a homework assignment that you can work on in class, and you'll have plenty of time to do it. So first of all, look at these different transformations, and we're matching them up with the graph that is correct. All right, so here we go. Let's see. This, I'm multiplying by 4. Where? Well, there's no parentheses, so that's outside. So what that is it's going to get more narrow because it gets vertically stretched. Which one looks like it got more narrow, and that's it? Well, C, of course. See, look, it got really narrow. And it didn't do anything else. That's it. Okay, so 1 is C. Look at 2. There's my parent function, x squared. What happened to it? We added 1. Where? Outside. Remember, when I add or subtract outside, that's vertical shift. Remember what we know about vertical shift? It is what it is. So what's a positive 1 vertical shift? It shifts up 1. Which of those graphs shifts up 1? Definitely A. Look at 3. We're subtracting 4. That's a shift. Where? Inside. That's horizontal. Horizontal shift. Remember the rule, guys? On the inside, it's the opposite. So that looks like a negative 4. So it's actually a positive 4 horizontal shift. So it shifts right 4. B shifts right 4. And then finally, you have this negative, which means it reflects. It's on the outside, so it's a vertical reflection, so it flips over the x-axis, D. So CA, BD. Okay, let's keep on cruising along. We're going to state the transformations. I'd love for you to follow along with me and actually say them when I ask the question. Give you a couple seconds to answer it, and then I'll pipe in. Look, what's happening? We're adding 5 inside. That's a horizontal shift. Remember the rule inside? It's the opposite. That looks like a positive 5, so it's actually a negative 5 horizontal shift. What's a negative 5 horizontal shift? It shifts left 5. Okay, next one. It's a negative. Okay, I don't care what the parent function is. It's absolute value, but it's a negative. Where? Inside. Well, that's a horizontal reflection. Guys, what kind of reflection is horizontal? It reflects over which axis? The horizontal axis? No, it reflects horizontally. It reflects over the y-axis. Okay, let's keep on cruising along. This one's got a couple of transformations. I'm subtracting 3 inside. That's horizontal shift. It's the opposite, so that's a positive 3 horizontal shift. That means it shifts right 3. And then this plus 9, where's that out at? It's outside. It's vertical shift. Remember, vertical shift is what it is. So what's a positive 9 vertical shift? It shifts up 9. Next one, I got a negative outside. That's a vertical reflection. Remember vertical, up and down. Up and down goes over the x-axis. So it reflects over the x-axis. But also, we've got this 4/5. Okay, so here's what I want you to think. It makes it wider, 4/5. It's less than 1, right? So it's going to get wider. Okay, where is this 4/5 being multiplied? Inside. Horizontal. Guys, what horizontal dilation makes it wider? A horizontal compression. Think about it, guys. You're compressing left to right. Or a horizontal stretch. Well, a horizontal stretch makes it wider. So this is a horizontal stretch. Okay, last two, and then we'll go to one more section. This has got 3 things going on. Look at that. Boom, boom, boom. So let's start with that 6. Well, 6 means it's going to get more narrow, right? Narrow. Well, it's outside, so that's vertical. Vertical dilation. Which vertical dilation makes it more narrow? A vertical stretch or a vertical compression? Well, definitely a vertical stretch. Okay, this minus 1 is subtracting inside. That's horizontal shift. It's the opposite, So that looks like a negative 1. So it's a positive 1 horizontal shift. That's a shift to the right 1. And then lastly, we've got minus 4 outside. That's a vertical shift, and it is what it is. What's a negative 4 vertical shift? It's going to shift down 9. I'm sorry, not 9, 4. Duh. I don't know what I was looking at. I think I got ahead of myself. I was looking at F. Now, this is a little bit of a tricky one. I want you to notice something. Notice how on the inside, both of these are divisible by 5. I would actually need to do that where I factor a 5 out. 5x divided by 5 is x, and positive 15 divided by 5 is 3. So technically this would change, and it looks like this. And now I can answer all the questions. Okay, here's what I mean. I'm multiplying by 5 where? It's inside. Now I know it's not inside these parentheses, but it's inside my absolute value. So that's a horizontal. Now think. 5 makes it more narrow. What horizontal dilation makes it narrow? A horizontal stretch? Like this? No, it makes it wider. Or a horizontal compression? Well, yeah, that makes it more narrow. So this is going to be a horizontal compression. Okay, next. This plus 3 happens inside still. So this is a horizontal shift. Remember, it's the opposite. So this is a negative 3 horizontal shift. That means it's going to shift left 3. And this minus 9 is on the outside. On the outside. Outside means vertical shift. So this one's going to shift, and it is what it is, down 9. Okay? So pretty simple. Hopefully you guys understand that. All right, we're going to do about 6 more, and then you can have your piece of paper. This one's very similar. It's just a quadratic instead of an absolute value. So look, I'm multiplying. I'm going to go a little faster. I'm multiplying by 0.4. Remember, that's going to make it wider because it's still less than 1. It's inside, so it's horizontal. What horizontal move makes it wider? A horizontal stretch. Look back up at your notes if you can't logic through it. Okay, look at B. It's got a couple things. I'm subtracting 7 inside, so that's horizontal shift. It's the opposite, so this thing's shifting positive 7, which means shifting right 7. That plus 6 is on the outside. That's vertical shift, and it is what it is, so it's also shifting up 6. Okay, let's keep on moving. This has a lot of stuff going on C. 1/2, remember, makes it more wide, makes it wider. It's happening on the outside. That's vertical. What vertical move makes it wide? Vertical compression. That plus 1 inside means horizontal shift. It's the opposite, so it's negative 1 horizontal shift. It shifts left 1. Then that plus 5 on the outside means vertical shift. It is what it is, so that thing is shifting up 5. Okay, let's stay right here. Multiplying by 3 on the outside, that's going to be narrow, right? It's greater than 1. It's on the outside, so it's vertical. What vertical move makes it narrow? A vertical yank it, stretch. That minus 6 on the inside, that's horizontal shift. It's the opposite, so that's going to actually be a positive 6 horizontal shift. So it shifts right 6. And that minus 2 is vertical shift. It is what it is, so it's going to shift down 2. All right, last 2, and then I will shut up and you can move on. This negative is a reflection. Remember, it's on the outside because there's no parentheses, So it's a vertical reflection, which means it's going to reflect how? Well, vertical. Vertical goes up and down, so it reflects over x-axis. And this minus 4, again, no parentheses. It's outside. That's vertical shift. It is what it is, so it shifts down 4. And last one, this negative happens inside, so it's horizontal reflection. Horizontal reflection means it reflects horizontally, meaning over the y-axis. This plus 6 is happening outside. Vertical shift, it is what it is, so this thing shifts up 6. Okay? So there you have it, guys. There's your notes, your examples that we've gone through together. Your homework will now be passed out. It's all 6 of these problems, and it will be due tomorrow. Okay, I'll be back, and we'll go through any questions that you have. But this worksheet should be making its way to you now, and I want you working on that for the rest of class. Okay, I hope that you have a good rest of the day, and I look forward to being back. See you again tomorrow.